Okay, let's take a look at this inverse derivative example. In the current text, this is number 270, but it's a great example regardless. So the direction is find the inverse derivative evaluated at a when f of x is x plus root x and a is 2. I underneath had wrote the formula for the derivative of the inverse, and I'd put a box around it here. So notice f prime, right? We need f prime, so let's go ahead and do that. That's probably the easy thing to explain here. The derivative of f is 1 plus, remember x root x is x to the 1/2, so 1/2 x negative 1/2, or 1 plus 1 over 2 root x. Okay, the confusing part, I think, is with inverses, we're so used to substituting a in for x. But with the inverse, this a value is actually y, right? If we look at it the way that it's written, we could change x and y and substitute in for x, but that's equivalent to just saying 2 equals x plus root x. Sometimes these are very difficult to find, and you may need technology. This one, though, it's actually a quadratic in disguise, right? If I set it equal to 0 by subtracting 2, what we do is like think u substitution. I'm not going to do u substitution, but if we said u is root x, then u squared is just x. And therefore, this is in the form of a quadratic, like u squared plus u minus 2. And when we solve for this, 0 equals, if we were to factor, that's u plus 2, u minus 1, right? So root x plus 2, root x minus 1. And if when we solve this, this one is impossible here. We get a square root equals a negative, so we could just not even count that. And therefore, square root of x equals 1, or x equals 1, right? Square both sides. So why is that, like, how is that relevant? Because in this example, we know the a value. This piece here says to take what you get for the inverse value and substitute it into the derivative. So since I have everything in terms of x still, I never changed it, this is the outcome of f inverse. So that is our x. So last, the formula now, to finish solving this, it tells us that the derivative evaluated at a, in this case 2, is 1 over, I need to plug in what the result I just got in for x into the derivative function. So that derivative function was 1 plus 1 over 2 square root 1, right? Not 2, because I needed it evaluated, I needed the inverse. So the inverse value is actually 1. And again, we got that by substituting a in for y and solving that way. So therefore we get 1 over 1 plus 1/2, right? So 1 over 3/2. And when we divide by a fraction, we multiply it and by the reciprocal. So 3/2 times 3/2 reciprocal is 2/3 times 1 is just 2/3. I'll kind of write what I just said out right there, right? Now, to take a step back, I had said this is the formula in this rectangle here, but remember that the derivative of the inverse is just the reciprocal of the original derivative. So honestly, if we just found the f prime of 1, right? So let's take our f prime, which was here, and we just did f prime of 1, 1 plus 1 over 2 root 1. And we know we get 3/2 because that was in the denominator. And the inverse just says it's the reciprocal of that result. That is what 1 divided by anything is. It's simply saying the reciprocal. And so therefore that makes sense that that was our end result here.